Welcome to the project demonstration of street light that glows on vehicle movements with day and night mode. So here the main application of this project to save the power regarding the street lights. So the power saving will be done with the help of the two sensors. One is light dependent resistor and IR obstacle sensor. So here we are using this obstacle sensor to detect the vehicles. Means whenever the vehicle movement is detected in front of this IR sensor, then it will check with the LDR. So if it is night time, then the system will switch on the LEDs for 3 seconds of time. As I consider the time for the 3 seconds is like the vehicle will be passed in a 3 seconds from the street lights. Just it's a demonstration purpose, we kept it as a 3 seconds, and in real time we can increase up to our wish. And the next, the whole system getting power supply from this cable. So we are going to provide the 230 volts input, and the transformer will step down the 230 volts AC to 12 volts AC, and that was input to this regulated power supply board. On this we can see the 4 diodes or act as full wave bridge rectifier. So we will get pulsating 12 volts DC, means AC 12 volts to pulsating 12 volts DC. So with help of this 1000 microfarad capacitor, we are going to remove the pulses. Nothing but this will act as a smoothing one, and then after we will get the smooth DC of 12 volts. And after this 7805 regulator. So before 7805 regulator, 12 volts power supply for this LEDs through this transistor board. And after 7805 regulator, we will get 5 volts power supply. So we are distributing the 5 volts power supply. One is for the IR sensor, one is for the LDR sensor, and one is for the comparator. And there is a green LED indication which will show the RPS status. And then, so when we switch on this kit, the system start reading input from these two sensors. Coming to the LDR sensor. So as you know that LDR nothing but light dependent resistor. Whenever the sunlight is, any lighting is increasing on the surface of this LDR, then the resistance between the two electrodes will be decreases. When the darkness is increases, resistance increases. So based on this resistance variance, we will get the variable voltage that will be identified by our comparator. And also coming to this IR sensor, so it has a 2 LEDs. One is IR LED transmitter, this transparent one, and this black one is the IR receiver. So whenever IR transmitter transmit the IR rays, if any obstacle is present in front of this sensor, then the surface of this object will be reflect this IR rays, and that will be received by this IR receiver, and then the system will inform to the comparator about the vehicle presence. When these two sensors satisfied in normal condition, nothing but obstacle is detected and lighting is less, then the system will switch on this LEDs with the help of the transistor board. Here we are using BC547 transistor. So the system will, the comparator will trigger the transistor will trigger this 12 volts power supply to this LED. So here we are using this BC547 transistor as a switch. So let us see the demonstration. Just give the 230 volts input to this plug. So once we switch on the kit, so it will check the input of the sensors. Right. So after some time it will be off. Now it is working mode. So as of now it's darkness, then the vehicle comes, the light on, and after some time it will be off. And so if the lighting is more, right, so if the vehicle comes, then there is no signal sign to switch on the street lights. And when it's dark, vehicle comes, light on, so it will passes away, and after that it will be off. Right. So this lighting is more, no indication of lighting on. So there is a light indication on this IR LED. We can observe that whenever the obstacle is detected, so the light will be on. So it will show the status of obstacle presence in front of the IR sensor. Right.